Hello, everyone, and welcome to our beginning of factoring. So, factoring is just like at the crux of all of Math 2 and of the crux of all algebra. So, I really want to make sure we stamp this idea. So, up to this point, for these last 3 days, we've been working with how to manipulate polynomials. We worked with how to add them, how to subtract them, even how to multiply them. All right? Now, today, what we're going to actually work with is how to factor them. All right, and in particular, what we're going to do today is how to factor quadratics with a leading coefficient of 1. So let's write out a basic quadratic as this function ax squared plus bx plus c. The characteristic of any quadratic is that this leading term here is of the power 2, or squared. Okay? These terms, a, b, and c are all coefficients or just numbers. Now, today we're going to work specifically with the factor of a is equal to 1. All right? Now, at the crux of all factoring is when it's a equal to 1, you're going to have something that multiplies to equal c but adds to equal b. Okay? So when you write out your factors for this, you're going to write those factors out as x plus or minus some number times x plus or minus some other number, where you add these numbers in here in such a way that the two numbers multiplied together is going to give you c, and when they add together is going to give you b. All right? Now, I'm going to go through two distinct processes of doing this for the sake of your convenience and for to give you the option to choose which one you're most comfortable with and you find easiest. So let's start with a pretty basic example. Let's say that we have the problem x squared plus 8x plus 7. All right? I'm going to go ahead and write out my factors like I had done up here as x plus or minus some number times x plus or minus some other number. Now I'm going to look over here and say, okay, I've got these two things, and I need something in this box here and this box here that multiplies to give me 7, but is going to add to give me 8. So put the puzzle together. This is the difficult part of factoring, is actually forming this puzzle in your mind that allows you to quickly see what the factors are. So I look at this and I see, okay, 7 times 1. Okay, 7 times 1 is 7. So I know that works and satisfies the condition that the two numbers have to multiply to be c, but do they add to be 8? So 7 times 1 is 7. 7 plus 1 is 8. So yeah, they do work. So let's go ahead, we can put this in here, x plus 1 and x plus 7, okay? Now we can always check our work by multiplying these out, and we should return this answer, and in fact we will. But now let's actually go through the second method, which, if you are all familiar with it, we call it the box method. So we're going to create a box here, and what we're going to do is in the upper left box, we're going to put our leading term, or our x squared. So in this box, we're going to put x squared. And in the far bottom corner over here, we're going to put our last coefficient, which is 7. Okay? Now on the outside here is going to be our factors. So I know here should be x and here should be x. All right? But what number, all right, what number is going to multiply to be 7 and add to be 8? Okay? So over here again, I'm going to put in here 7x, and over here I'm going to put 1x. All right? And how I'm going to factor this is I'm going to say, okay, I know that 7, all right? I know that 7 times 1 is 7, and 7x plus 1x is 8x. So over here, I'm going to put this down here as x plus 1. And over here, it's x, oh, excuse me, this should be 7. Go ahead and erase that. So this should be x plus 7, and this should be x plus 1. All right, we can check our work by saying, okay, x times x should give me x squared, x times 1 should give me 1x, 7 times x should give me 7x, and 7 times 1 should give me 7. All right, so we factored it out, and these are our factors, x plus 1, and x plus 7. All right. Now, you guys can choose which way you think works best for you. I've found that in my past that this is the easiest way, but I know this way systematically and visually kind of makes more sense. So let's go ahead and go through another example. All right. For this next example, let's go ahead and work with this problem. We're going to do n squared minus 11n plus 10. All right. So let me kind of segment this off so we know it doesn't get into our other work. So this is our problem here. I'm going to go through this in both methods once again. So what I'm looking for here, all right, are two factors, n plus or minus some number times n plus or minus some other number that equals that when those two numbers are multiplied together, they give you 10, but when they're added together, they give you negative 11. So how can two numbers multiply together to give you a positive, but add to be a negative? Okay. Well, if we think about it, we know that when you multiply a negative by a negative, those negatives become a positive. And when we add two negatives, they remain a negative. So I know in here that I need two negative numbers. Now, what two numbers multiplied by 10 but give 11? Start out with 10 times 1. Does 10 times 1 equal 10? Yeah. Does 10 times 10 plus 1 equal 11? Yeah. So our factors are going to be n minus 10 and n minus 1, because negative 10 times negative 1 is positive 10, and negative 10 plus negative 1 is negative 11. All right? Now let's try using the box method once again. Okay? All right. Actually, let's go back. We're actually going to create a box here. Let's create our box. Now let's go here, draw our lines. So we create a 2 by 2 box. Now remember, in the upper left corner, you put your leading term of n squared. All right. In the other box at the bottom, you're going to put your last term of 10. Now, what you're going to do is you're going to multiply this n squared by the 10 to give you 10n squared. And now, in these two boxes, you need two things that multiply to give you 10n squared, but add to give you negative 11n. All right, kind of tricky, right? So let's go ahead down here. We can put this in so we know that something that multiplies to give you 10n squared is going to be 10n times n, right? 10n times n is going to give you 10n squared. But 10n plus n is 11n. We need those to be negative, so we have to change the sign somehow. So let's try putting a negative in front of each one. If we do negative 10n times negative n, we still get the 10n squared, and negative 10n plus negative n is equal to negative 11n, which is what we're looking for. So this is our factored box here. Now we need to figure out what our factors are from it. So I know up here I'm going to have n and n. Now, n times what gives me negative n? All right, I know that's going to be negative 1. So n times negative 1 is negative n. Now, what times n is going to give me 10n? Negative 10n should be minus 10. So n times n gives me n squared. N times negative 1 gives me negative n. Negative 10 times n gives me negative 10n. And negative 10 times negative 1 gives me positive 10. We have completely factored out our answer and solidified our solution as n minus 10 times n minus 1. All right. So at this point, everyone, I hope you guys are becoming a little bit more familiar with this process of combining, factoring and combining and using the box method versus my method. Like I said, it's completely up to you which method you think is the best. But for right now, let's go through a couple more examples. I want to try and get through 2 more examples before we call it a day. All right. So let's go through the example of 2x squared plus 8x minus 12. All right. Actually, excuse me. It should be minus 24. All right. Now, notice here that we're working with factoring polynomials that have a leading coefficient of 1, but whoa, I put a 2 in there, okay? How do we fix that problem? All right. To fix that problem, the first thing we check is, can I pull anything out? Can I take 2 out of everything? And I see that, yeah, I think I can. I can pull a 2 out and rewrite this as equal to 2 times x squared plus 4x minus 12. All right? Now this becomes something we can factor pretty easily, just with a 2 out front. All right? So anytime you have a leading coefficient that is not 1, you need to make sure that if you can pull it out to make it 1, you do that. Okay? Make sure you divide each term by what you pull out. So I've divided 8 by 2 to give me 4, negative 24 by 2 to give me negative 12. The other important thing here is to make sure that when you write your factors out, you write this as equal to 2 times x plus or minus some number times x plus or minus some other number. Okay? Now what are my two numbers in this factors? My numbers have to multiply to give me negative 12, but add to give me positive 4. So my two numbers have to multiply together to give me a negative. I know that the only way that two numbers multiply together to give me a negative is if one is a positive and one is a negative, right? So positive plus a negative is equal to a negative. A positive plus a positive times a positive is equal to a positive. And a negative times a negative is still equal to a positive, all right? So the only way to get a negative from a multiplication is to multiply a positive times a negative, all right? So we know that I'm going to have one negative and one positive here. Now I also know that the 4 is positive, all right? So what two, one positive and one negative number, multiply to give me negative 12, but add to give me 4? All right, so let's go through the process of trying each possibility. We could do 12 and 1. Is there any combination of positives and negatives from 12 and 1 to give me 4? I don't think so. So what other things multiply to give me 12? All right, what about 6 and 2? 6 times 2 equals 12. Well, negative 6 times positive 2, negative 6 plus 2 will give me negative 4. So that doesn't work, but wait, I still get a 4. So what if I do 6x plus 6 and x minus 2? All right, 6 times negative 2 is negative 12, and 6 minus 2 is positive 4. So that's our fully factored out expression. So this is our answer. All right, now let's try doing the box method. Okay, again, I'm going to have already pulled out my factors, or I'm going to already have pulled out my 2. So when I draw this box, I'm only going to factor that first part and remember to tack on the 2 at the end. All right, so in this first box up here, I'm going to put x squared. In this box down here, I'm going to put negative 12. And then I'm going to multiply them together. X12 times negative 12 gives me negative 12x squared. And I'm looking for two numbers that multiply to give me two factors that multiply to give me negative 12x squared and add to give me positive 4x. All right. From our previous discussion, those two numbers have to be a 6x and a negative 4x, or excuse me, negative 2x, because 6x times negative 2x gives me negative 12x squared, and 6x minus 2x gives me 4x, which is what we wanted up here. All right. When we write out our factors, we have x over here and x over here. Over here, what times x gives me negative 2x? It has to be minus 2. And what times x gives me 6x? That has to be plus 6. So our factors are x plus 6, x minus 2, and it's all multiplied by a 2. So that would be the same thing as over here, 2 times x plus 6 times x minus 2. All right? So everyone, I hope this was helpful in learning a couple different methods of how to factor these variables. I will post an example video with a couple more examples as well to post under the direct instruction. Remember, show up to class, watch that live video, and use these videos when you're doing the independent practice. Thanks for your patience, everyone, and good luck with the material.